Alright, I'm going to go over a brief overview of xylem and phloem. Remember, these are part of vascular plants. Xylem is mainly transporting water and minerals from the roots to the shoots, so going up the plant. And phloem, while it's showing it moving down, it can move throughout the plant. That could be down, it could be up and to the side, because it's transporting carbohydrates, in this case sucrose, from source areas of the cell to sink areas where that sugar needs to be stored. So while there's two kinds of vascular tissue, we're going to focus first on xylem, remember phloem being the other, and xylem's conducting water and minerals from the roots to the shoots. There's two conducting elements, the truncates and the vessel members, and on a microscopic view this is how they would look, our phloem and our xylem. Now xylem's transporting that water and those minerals through these vessel elements and truncates. Both of these are dead at maturity and have primary and secondary cell walls. Remember, we are in a plant here. In the pits here, the secondary wall is thin or missing, allowing water to flow laterally. So maybe we can see that a little bit better here, where we're getting some lateral movement of the water. Now again, this is still occurring from the roots all the way up to the shoots. And how it looks on a microscope, while it may not be stained this same color all the time, the xylem is this larger region. Some people consider the xylem to look like straws. It's maybe a way to help you remember it, even though there are these kind of perforated plates that are occurring. So it's not 100% true to say it is like a straw, but it does certainly look like them on a microscopic view, in contrast to the much smaller phloem that is involved with active transport. So mentioning phloem, let's look at that in a little more detail. So phloem is nutrient-conducting tissue. It's in close relation to companion cells. There's two conducting cells. There's these sieve tube members and these sieve cells. You can see an image of that here. Phloem transports sugars and other items. In angiosperms, which are flowering plants, the sieve tube elements contain sugar solution, and these sieve tube cells are surrounded by various supportive cells. So when I say close relation to companion cells, these companion cells can be either adding sugar or carbohydrates to the phloem or taking it out of the phloem. Translocation in the phloem. Phloem is composed of cells, and the sieve tube elements. Phloem sap, as it may be referred to, travels through perforations called sieve tube plates. Neighboring companion cells carry out metabolic functions for the sieve tube elements and provide them with energy. These lateral sieve areas connect the sieve tube elements to the companion cells. So what does all this kind of summarize and mean? Well, these companion cells are helping add or take away sugars. Again, moving sugar requires energy, requires active transport, so these companion cells, in these cases, are the ones responsible for kind of this loading or unloading of the phloem sap. Kind of this direct comparison for xylem and phloem. We see xylem, all the arrows going from, in this case, the shoots from the roots all the way up to the shoots, that one direction. From the roots, working its way up through the plant to the shoots. Now phloem, we see the arrows going up, arrows going down. It's a two-way flow. There's water and food being exchanged here. There's companion cells, there's food storage cells. Again, this is moving our carbohydrates, our sugars throughout the cells here. So the plant can take energy captured through the process of photosynthesis in leaves and can bring them to storage organs. Another good comparison here is our xylem. Again, shoots are up the top here, and our roots are down here, and that water is moving from those roots to those shoots, going to the shoots. Phloem can go in both directions here. Translocation to the sink. The sink is the area that's taking on those sugars, needing those sugars. Sucrose is actively transported from the source cells into sieve tube elements. This causes water to enter the phloem from the xylem, as we see here. The resulting positive pressure forces the sucrose water mixture down towards the roots, where sucrose is unloaded here. The root, an example, would be our sink cell. Transpiration causes water to return to the leaves through these xylem vessels. So what is this process of transpiration that I mentioned? Well, it's the simple movement of water through the plant. Cohesion theory of sap accent is shown here. Evaporation from the cells in the leaves produces negative pressure, and kind of that pulling force, and that gradient causes water to move upward from the roots through the xylem. So here's our roots, here's our water molecules entering the roots here. going up through our trunk of the tree and exiting out the stomata, which is in the leaves at the top of the plant here. Now, of course, water's coming in here and leaving out here also, but this kind of shows you the long way that water can take. And our root cells, compared to our atmosphere, the atmosphere is more negative, indicating water is moving from the roots, where it's high water potential, to this area of low water potential gradient, and being essentially pulled out of the leaves there. Hopefully this was helpful in explaining some of the important functions xylem and phloem perform in vascular plants.